When chemists deal with gases, our main concern is how is the pressure affected. Now, pressure can be affected by several variables. A couple of these variables actually fall under a couple of gas laws. The first gas law we're going to go over is Boyle's law. Boyle's law states that the pressure is inversely related to volume. So what this means, if I decrease the volume, I increase the pressure. Take this piston, for instance. If I decrease the pressure, the volume by half, I double the pressure. Now, the second law is called Charles's law. It states that pressure is directly related to temperature. So in a closed system, if I heat up the piston from 200 to 400 degrees, the volume actually, in this case, increased. But if I held the volume steady, the atmosphere pressure would actually increase by the same amount. So mathematically, Boyle's law, pressure is inversely related to volume. It actually can be derived into this following equation. P1 V1 equals P2 V2. Charles' law is the same, can be derived into equation P1 over T1 equals P2 over T2. So what these two equations allow us to do, if we know the initial conditions of a system, if we change the volume or change the temperature, we can understand how the pressure is going to be changed. Let's go use these equations in two problems actually to understand them better. If you have a piston at 298 degrees Kelvin with 1 atmosphere of pressure and 1 liter of volume, what is the resulting pressure if A, the volume was decreased to 0.130 liters, and B, if the temperature was lowered to 200 degrees Kelvin? First equation is going to be Boyle's law. P1 V1 equals P2 V2. We know the initial conditions, 1 atmosphere and 1 liter equals 0.130 liters. We're solving for X, or atmospheres. We're left with 7.7 atmospheres of pressure is the final pressure. So the second question, P1 over T1 equals P2 over T2, is Charles's law. 1 atmosphere over 298 degrees Kelvin equals X over 200 degrees Kelvin. We're left with 0.67 atmospheres of pressure.